All right, question 72 and 73. And these questions will be used what is called the expected value. And basically, the expected value is like the average amount of money or whatever gain or a loss that you'll receive, or have to pay out by performing in a probability experiment numerous times. So another word for expected value can also be the mean or the average. And you can actually connect the mean formula with this, and it will be the same type of procedure. So to find the expected value, you're going to multiply the numerical outcomes x with its corresponding probability p of x, and then find the sum. So let's start off easy and then work our way up. Number 72 says find the expected value for the random variable, which is x, in this case, which is y, excuse me, and we have our probability distribution. So to find the expected value of y in this case, so I'm going to call this E of y. This is going to equal to, well, it's the y values times the probability of getting those y values. So y1 times the probability of y1 plus y2 times the probability of y2 plus y sub 3 times the probability of y sub 3 plus y sub 4 times its probability y sub 4. So let's compute that. The expected value in this case is going to be 6 times 0.4 plus 8 times 0.4 plus 10 times 0.16 plus 12 times 0.04. So that's going to equal to, when I multiply 2.4 plus 3.2 plus 1.6 plus 0.48, and that's going to equal to 2.4 plus 3.2 is 5.6, plus 1.6 is, I believe, 7.2, plus 0.48, which is 7.68. That is the expected value for this probability distribution. Now we're going to do the next question. Number 73 says, zoom out a little bit. Suppose a charitable organization decides to raise money by raffling a trip worth $500. If 3,000 tickets are sold at $1 each, find the expected payback for a person who buys one ticket. I love raffles, even though they're kind of rigged. All right, so there are two outcomes in this case. The outcomes are you win the trip or you lose the trip. So you either win or you lose. If you win the trip, you win a trip that is worth $500. And if you lose, you do not get the trip. So I'm going to write here, the trip costs $500. If you win, you only win $499. If you win, you win $499. Why is it $499? Because remember, you spent $1 to participate. You spent $1 to participate. You profited $500. Rather, you received $500. Your profit was $499. you are leaving with something that is $499 more than what you came in with. That is if you win. So let's put if you win. If you lose, guess what? You lost $1. You lost $1. You don't lose nothing in this case. You spent your money. You didn't get nothing. You lost $1. So if you win something that is actually worth $499. And if you lose, you're losing $1. We're going to put a negative because it is a loss. It says a trip, which means it's only one trip. That means only one trip out of 3,000, only one ticket out of 3,000 tickets gives you the winning prize. So the probability of you winning is 1 out of $3,000. And the probability of you losing or not winning, let's put lose actually. The probability of you losing, that is 2,999 out of 3,000. Once again, you sold 3,000 tickets. There's only one prize, which means only one ticket out of 3,000 guarantees you the prize. The other 2,999 tickets means you will not be receiving the prize. So this is definitely, well, it's not even rigged. It's for charity. So excuse me, it is a charity. I take that back. So basically, let's organize our data. We have our X and our P of X. So we have our winning amount, which is $499. And the probability of winning is 1 over 3,000. Then you have your losing, which is you lost $1. And the probability of that is going to be 2,999 over 3,000. To find the expected value, we're going to zoom in now. We're going to multiply each numerical outcome with its probability. So 499 times 1 over 3,000 minus $1. Because remember, we're adding a negative. So a positive with a negative is a negative. And that's going to be 2,999 over 3,000. Let's multiply those together. Every whole number has a denominator of 1. And we multiply fractions straight across. So that's 499 over 3,000 minus 2,999 over 3,000. Let's straighten this out. When we subtract that, I believe that's minus 2,500 over 3,000. And when we divide that, that's going to be approximately 83 cents. Let's go back to the pen. Oops. 0.83. So you're expected to lose 83 cents for every ticket you purchase. I think that's right. That should be, because that's 25 over 30, which is 5.6, which is about 83 cents. Let's double check the math real quick. Yep, that works. All right, guys, that is it to the video. Hopefully you understand how to find the expected value. Pretty straightforward. Just make sure that you're satisfying the conditions of the questions, and I'll catch you in the next one. Take care.